We've already talked about sound, we've talked about frequencies, amplitudes, and now we want to connect things, pull it all together. And you need to be able to do this. If you were a sound technician working at a radio station, you would have to know about sound. If you played in a band for a profession, you'd have to know about sound. If you were a student getting ready to take a quiz on sound, you would have to know this. So, this is how we make connections. We know that sound waves must travel through matter, and matter comes in three phases, mostly: solid, liquid, and gas. We know that sound waves travel the fastest when the particles are closest together, which means they will travel the fastest in a solid and the slowest in a gas. We also know that frequency, how fast that sound wave is moving, pertains to pitch when it comes to sound. We know that the higher the frequency, the higher the pitch. So we know the fastest sound wave is going to have the highest pitch. Now think about our tuning fork experiment. We had a tuning fork with a string attached to it and a tuning fork without a string. Now the tuning fork with a string, well, string's a solid. Tuning fork with no string, the sound waves had to go through air. Air is a gas. Because a string is a solid, we know the sound waves are going to move fastest through the string and slowest through the air. Because a string is a solid and it has the highest frequency, we know it's also going to have the highest pitch. And likewise, the tuning fork with no string is going to have the lowest pitch. Therefore, the tuning fork with the string has a higher pitch than the tuning fork without a string, because the sound waves in the tuning fork with a string travel through the string to your ear, and the sound waves without a string travel through the air to your ear.